Hi, everyone. Can you hear me okay?
Yep, we can hear you very clearly.
Wonderful. Let's go ahead and get started. Again, I'm Roger Barga. I'm General Manager of Robotics at Amazon Web Services. My team builds and operates the service called AWS Robo Maker, and our team is committed to building cloud services that enable our customers to build smarter robots, to build the robots faster, and to build safer robots once they're put into production. And I'll tell you a little bit about our service in my presentation today. Next slide, please. What's really caught our attention is just the incredible rise in the use of and demand for robots, especially in areas like logistics, healthcare, and consumer applications of robotics. Obviously, logistics is something that Amazon does quite a lot of, and we are seeing ourselves the explosion of autonomous robots, which are becoming the standard for moving products in our warehouses, for fulfilling orders. We've seen a spike in the use of robots in healthcare, and I have a customer I'll tell you about a little bit later in my talk. But we're also seeing an explosion of robots in the consumer space where they can be used around the home and other areas. And to meet this demand, robotics companies are developing increasingly advanced applications, especially as they compete with their competitors and try to differentiate their offering. Next slide, please. Now, this audience probably needs no introduction to just how difficult it is to build a robot, let alone the robotic application that runs on it. All the way from the moment you start to build, how many diverse skill sets you have to have in your team, the iterative development that it takes to get it right on the software, and then once it comes time to test, not all your developers have access to a robot, so simulation starts to become important, let alone once it's time to actually deploy a robot into production, your robot in the application into production, and then manage that over time. Because odds are you're going to have different versions of your robot with different versions of the application. The bottom line is we see a lot of undifferentiated heavy lifting, work that frankly doesn't add value to the robot you're trying to build or the application. It's just unnecessary work that you have to do. And this is what we're trying to focus our service on. What can we build and provide that actually allows you to spend more time focusing on your robot. Next slide, please. So advanced robots do require advanced building tools to build them. One that I'm going to focus on in my presentation today is cloud-based simulation. And we have used cloud-based simulation to help a wide range of our customers, from iRobot to Milvus Robotics, Bastion, Takanada, Woodside, JPL, Husarian, and Sheeta Mobile. And I'll tell you a little bit about how we've worked with these customers to enable them to build better robots and get them to market faster with fewer errors. Next slide, please. So some of the benefits that these customers have experienced through cloud-based simulation, they've reduced their cost. Every developer on their team has access to a digital twin for their own virtual robot to actually test their application as they're building it. And they've experienced that they can reduce the cost of failure in development by iterating fast and trying different ideas out. They've increased the safety. Some of our robots are actually operating around people, sometimes in multi-robot cases, and they can actually test in simulation to ensure the robot is going to maintain a safe distance from the individuals and other robots under all possible conditions. These simulations can actually run faster than real time or wall clock time. So the time to actually test an 8-hour simulation could often be done in less than an hour, allowing a developer to test out a wide range of conditions while they're out taking lunch. And as you'll see later in my talk, some of our customers have actually increased the test coverage because they can run these simulations faster and scale them out on a cloud service. They can actually add more and more tests to ensure that their robot continues to improve its performance over time, and then scale those out. And as you'll hear, some of our customers have set up regression tests so that to ensure a developer doesn't degrade the performance of the robot by making a small change to their app, they can actually test all possible conditions in simulation before they allow that developer to check their code in. Again, the business outcomes: faster time to market, increased feature velocity during development, and less defects actually getting put out in production where your robot can have a really bad day. Next slide, please. Now, it's reasonable to ask, hey, with all these benefits, why aren't more people doing this today? Or why weren't they doing it before? Well, it's actually very expensive to create a 3D model or simulated world in which your robot's going to operate. Can you go back, please? I think you've got the automatic timings driving my presentation. I need you to go back one more slide, please. Thank you. It takes a lot of hardware. When you want to run these large-scale tests, you may need hundreds of machines, and that's expensive to maintain all those machines and own them. You want to have a consistent test environment. I need you to go back again. Thank you. Consistent environment across all of your engineers, and actually integrating a robotic simulation system into your CI/CD system or whatever you're using to manage your code deployments gets to be a little cumbersome as well. We can go ahead and advance the slide now. Thank you. Great. So what did we do in AWS Robo Maker simulation? It's cloud-based simulation. You can start a single simulation while you're doing iterative development, or you can start hundreds of them up. It's reliable. We have built-in monitoring to ensure that your simulation is actually running, making progress, and you can actually set conditions under which you'd like to exit the simulation. If your application encounters an error or your robot does something it shouldn't, we're monitoring it for you. It's fully managed. You don't have to actually think about how to set up a service or a piece of hardware. You can choose different versions of ROS, different versions of Gazebo, that's your startup stack, and start your development. And we offer you these options throughout. And what I'm not going to talk about today is we provide open source ROS packages to integrate your robot with cloud services securely. So you can add speech recognition, you can add image processing, streaming logs off of your robot to the cloud for analysis. And all you see is a ROS package that you're able to take advantage of. And we've tried to make this ridiculously cheap. We give you one simulation unit, which is a virtual CPU and 2 gigabytes of memory, for basically less than 6/1000ths of a penny per minute. And we automatically scale based on how complex your simulation is. Next slide, please. So here's one of our customers, who I mentioned earlier, a forward reference to a healthcare hospital cleaning vacuum. Milvus Robotics, they built a disinfecting vacuum robot. They wanted to increase their code release velocity while improving their test coverage. Basically, getting access to hospitals right now is very difficult. We provided an open source hospital world, which they used, and they generated a couple themselves as well based on that model, which they could use for actually testing their application to ensure 100% cleaning coverage throughout the hospital. And they wanted to actually scale all these tests out. So we worked with them to integrate their CI/CD code deployment system into our simulation. They wrote all the tests in RoboMaker simulation. Next slide, please. And so now every time a developer attempts to try out a new idea in their code, it gets tested in simulation. Every time they get ready to attempt a deployment to the actual robots in production, they run a suite of simulations to ensure the robot is running correctly. And they've actually seen a huge improvement in code quality as well as developer productivity. Again, Milvus Robotics. Next slide, please. Many of you are probably familiar with iRobot. They build a wonderful family of cleaning robots for the home. They had invested in tests before, but they actually wanted to increase their test coverage for different floor layouts. They have certain scenarios they're concerned with. One's called the robot kidnap, where someone can pick up one of their cleaning robots, walk it across the room, and drop it down. And they have to make sure the robot can actually continue not only cleaning, but find its way back to its powering station. So these are things they test for, and they were actually noticing that errors were being deployed into production and causing their customers to have a bad experience. And they wanted to both increase their testing, but also allow their developers to move as fast as possible. Once again, we worked with them to integrate RoboMaker simulation into their CI/CD system for checking in code, but also their deployment system for updating robots in production. Next slide, please. Because this could run so fast, and I'll give you some hard data in a second, they were able to add dozens of new house types, furniture layouts, and add new scenarios that they basically wanted to protect against. Next slide, please. So today they're running 5,000 tests every day, a 50 times increase over what they used to be able to run. Every time a developer attempts to check in code, they run 60 automated tests on each code commit. And they're effectively vacuuming over 250,000 square feet per day in simulation to test out their application. They can do 12 hours of robot runtime in 8,000 square feet. of vacuuming on each code submission in one of those tests. They're validating across 5 different robot types in their product suite. And they were able to reduce what was 3 weeks of testing for just that robot kidnap scenario I mentioned earlier down to 1 hour. And that's that ability to actually run things faster than real time and scale it out across hundreds of machines. Next slide, please. Solaris JetBrain was yet another customer we've worked with. They too are finding it difficult to run simulation on their local machines. It was really hard to ensure code quality. They had team members using different versions of ROS, having different simulation setups, led to a very long time to get new developers onboarded and part of the team, plus having consistency across the entire team for both simulation and for testing. Once again, we worked with them to build a fully managed cloud-based simulation infrastructure that their entire team could use. And they're also using our cloud IDEs to ensure that they have consistent development across their team. Next slide. And here we see a quote that basically, as their team has been growing, as their company's growing, they're able to onboard engineers much, much faster for their new developer. They're able to ensure consistency and quality across the code base, even though they have dozens of developers working on it. So again, it's just increased the quality. They can run faster, they can build a higher quality product and ensure that errors don't get pushed out into production. Next slide, please. There's something else that people are using simulation for as well. Because some of you may be familiar with AWS Deep Racer. Deep Racer is an autonomous vehicle, a little race car. It's, I think, a 1/64th the size of a real car. Next slide, please. And Deep Racer is programmed without writing a line of code to drive around a track using reinforcement learning and RoboMaker simulation. A reinforcement learning agent, which knows nothing about driving, is put into behind the wheel of a car in simulation. Because we can run these simulations in parallel, we start dozens of different racetracks and driving configurations to make sure the machine learning model generalizes. The Deep Racer car makes a series of mistakes. Periodically, those errors are collected. Reinforcement learning builds a better reinforcement learning agent through machine learning, deploys it back out to all the cars in simulation, and this process continues until, next slide, please. Now, this was a very early stop and test. We deployed using RoboMaker fleet deployment to deploy over the air the application to the robot. As you can see, it's still struggling, but it has learned how to drive around this little track. In real contests that we hold around the world, the car drives around the track in about 6 seconds. So you can see this car has still a lot to learn. But again, you can actually train your robots in simulation without actually putting the physical device out into the real world. Again, it keeps it safe, but we're also seeing how we can program new behaviors in robots for navigation and manipulation in simulation. And my team will have much more to share with you about that later, early next year. Next slide, please. So if you think about what is simulation, on the left, you have to take a model of your robot and you have to take a model of your simulation world. You plop that into a simulator such as Gazebo, and you can, as a result, you can get testing data out of it to ensure your robot is going to clean all the floors it should clean. You can get training data for reinforcement learning. You could even use the data to get synthetic data for machine learning applications, which I'm not going to go into today, but this is kind of the role simulation plays, and what are the inputs and what are the outputs. Next slide, please. Well, the key is that when it comes to testing, you can test robots more robustly if you have a large amount of testing scenarios, all sorts of different home environments, such as what iRobot exposes their cleaning vacuum to. And again, with training, the more trained scenarios I can expose my robot to in machine learning, I can actually get a lot more performance out of my machine learning model by giving it a lot more different environmental scenarios. Next slide, please. So what you can see is that ability to generate those simulation worlds becomes a little bit of a bottleneck in applying simulation for generating hundreds of tests or thousands of racetracks for machine learning. So, and again, it can take thousands of dollars to create one of those simulation worlds. Next slide, please. This is why we recently announced a new capability for AWS RoboMaker called WorldForge. We're focusing WorldForge on residential environments, apartments, and homes right now, but we will be adding fulfillment centers, warehouses, grocery stores. It makes it possible to automatically create hundreds of predefined randomized simulation worlds that mimic real-world conditions. We have out-of-the-box 3D assets and world templates. So what that means is you could say, I want to build an apartment. We have that as a template that you can start from. You can see hundreds of assets that you might want to find in an apartment or a home, such as a bed, a table, a chair. You can select these items. We know where they should be in the house because this is part of what our service knows. We know where they should be placed and what should be placed around these objects. And we'll generate a world for you within minutes versus what could take weeks or months to generate that simulation world. We do that for about $1.50 to generate that simulation world versus the tens of thousands of dollars that it can take for you to actually go create one of these worlds. And we can actually do this concurrently for hundreds of worlds. And we actually generate these worlds probabilistically. That means each world is different from the others that came before it. And we ensure that by computing metrics, we throw away worlds that might be too close because we want your robot application to be exposed to a diverse range of conditions, all possible conditions, in fact. We're adding new features to add clutter or random objects we might drop around in the environment. But we will generate these simulation worlds for you, which you can then download, edit, add your own items in the room. And it's fully integrated with RoboMaker simulation, which means you can then drop it into a gazebo-based simulation and drop your robot into this environment to see how it's going to perform under all possible circumstances. If you were to look at the camera or sensor that was on the robot as it goes through the simulation world, you'll see high-quality rendering images of what it's seeing, so you can basically get synthetic data off of it and see what the robot is seeing as it goes through these various rooms. Next slide, please. So if you were to ask, what is the role of the cloud in the future of robotics? Well, we have intelligent cloud services running on the cloud that can enhance the local processing on the robot, such as speech processing, such as image processing, machine learning models hosted in the cloud. And since you can improve those models in the cloud, you don't have to necessarily update your robot. And yes, we understand there's certain processing that needs to run locally on the robot. We're looking at how can we augment that with cloud services without having you add extra processing or install extra software on the robot, but instead take advantage of cloud services. You can use simulation to test your application correctness, both when you're developing your application, but you can also build suites of tests in simulation and integrate that and ensure the performance of your robot across a wide range of conditions before you deploy that application into production where the robot's operating. And simulation combined with imitation and reinforcement learning can be used to program robot actuation, robot navigation, and presents a very compelling opportunity for us in the future on how we program our robots. Next slide, please. So we want your input. You're welcome to email me directly. You're welcome to take your phone and take this little CAPTCHA and click it. There is a survey there where we're asking for your input on what new simulation engine should we support in RoboMaker simulation? What new features would you like to see in simulation to help you to support your development and management of your robots? Welcome to any feedback you might have on what we might offer. We're committed to both ROS, we're committed to Gazebo, we're active contributors in the open source software, and we're here to actually, and we promote its development. When I talk to developers and other companies, we are advocating that they use ROS, that they become members of ROS-Industrial, and they become makers, not just takers of open source software and contribute back, just as our team is doing. So thank you for your attention this morning, and I hope you have a great rest of the meeting.